How do we transform expressions with rational exponents into radical form and radical expressions into exponential form? These are the questions we will answer for today's video tutorial. But before I start, please don't forget to subscribe to my YouTube channel and hit the notification bell for more updated contents. So let's start learning this math lesson now. Hello, dear math buddies! It's me, your math instructor, Sir Sherwin from Sherwin Math Tutorial. As what I mentioned earlier, today we will learn on how to transform expressions with rational exponents into radical form and vice versa. And to start, let us first define a radical expression. When we are asked to define radical expression, it is an expression containing radical symbol or radical sign. It consists of the following: the index, which is the degree of our radical expression, the radicand, these are the expressions inside our radical symbol, and the exponent of our radicand. Let's also review our ideas with respect to the rational exponents. When we are talking about rational exponents, these are fractional exponents. And this expression can be written into radical form. So our task now is to simply transform our expressions with rational exponents into radical form and radical expressions into exponential form. With this, let's try to have our first example as we transform expressions with rational exponents into radical form. Supposing we have a raised to m over n. In this certain expression, our rational exponent would be m over n, while a is considered as our base. So for us to write this one into radical form, it must have first a radical symbol. And our base here, which is a, will serve as the radicand of our radical expression. So this is our radicand. While m, which is the numerator of our rational exponent, will serve as the exponent of our radicand. And our n, which is the denominator of our rational exponent, will be the index of our radical expression. So this is our index. So this is how to write the expression containing rational exponent into radical form. Let's have our second example. Supposing we have 3 raised to 1/2. Again, our base will serve as the radicand of our radical form, while the numerator of our rational exponent will serve as the exponent of our radicand, and the denominator again will be our index. To write this one in simplified form, we can have this as square root of 3. For the reason that it is understood that the index here is 2 because the lowest possible index is 2. And if our expression don't have an exponent written on it, it is also understood that there is an exponent of 1. So we can write square root of 3 raised to 1 as square root of 3. So that would be the radical form of 3 raised to 1/2.
Easy!
Let's have the third one. So if we have 4 raised to 2/3, this expression can be written into radical form as our base will be the radicand, the numerator will serve as the exponent of our radicand, and the denominator will serve as our index. So we have cube root of 4 squared. And of course, 4 squared can be simplified as we multiply 4 by itself. So 4 squared is 16. Therefore, 4 raised to 2 thirds can be written into radical form as cube root of 16. So it is read as cube root of 16. So we are naming our radical expression according to its index. Let's have the fourth one. So if we have 2a raised to 2 thirds, it follows that the expression 2a is raised to our rational exponent, which is 2 thirds. This means we can write this one as, again, 2a will be our base, so it will be our radicand. The numerator will be the exponent of our radicand. So it is very important for all of us to place a grouping symbol because the radicand itself is raised to the squared unit. Then, our denominator would be our index. For us to simplify our radical form, using the law of exponent, and that is power of powers, we will multiply our exponent inside our grouping symbol to the exponent outside our grouping symbol. So 2 has an exponent of 1. Using the power of powers, we will multiply the exponent inside our grouping symbol to the exponent outside our grouping symbol. So it is understood that 2 has an exponent of 1. So 1 times 2, that would be 2. A has an exponent of 1 also. So 1 times 2, that would be 2 as well. Then, 2 squared can be simplified as we multiply 2 by itself. So 2 squared, that would be 4. Then copy a squared. So this would be the simplified form of our radical expression. And this would be the radical form of our expression containing rational exponent. Let's have the fifth one. We have 2a raised to 2 thirds. In this case, let us also be particular with the grouping symbol. Comparing our expression in our example number 5 to our example earlier, this expression don't have a grouping symbol. This means only a is raised to 2 thirds. So only a will be transformed into radical form. Again, a is raised to our rational exponent, and this is the only expression that will be transformed into radical form. So we will have to copy our numerical coefficient, which is equal to 2. Then we will have our radical symbol. A will serve as the radicand of our radical expression. The numerator, which is 2, will be the exponent of our radicand. And 3 will be the index of our radical expression. So we can write our radical form now as 2 cube root of a squared. So this would be the radical form of our expression containing rational exponent. This time, let's do the opposite now. Let's simply transform our radical expression into expressions with rational exponent or the exponential form. So how will we transform this one? Let's have our first example. So if we have nth root of a raised to m, it is considered that in writing this one into exponential form, our radicand will be the base of our expression with rational exponent. The exponent of our radicand will serve as the numerator of our rational exponent, and our index will be the denominator. Again, our radicand will be the base of our rational exponent. Then, our exponent of the radicand will be the numerator of our rational exponent. And the index will be the denominator of our rational exponent. So that is how to transform our radical expression into expression with rational exponents. Let's have our second example. We have fourth root of 81. So how will we transform this one into radical form? Here, we notice that our 81 is a perfect square and at the same time a perfect fourth power. So 81 can be written in exponential form as 9 squared or 3 to the fourth power. So we can write this one as fourth root of 3 to the fourth power. Because multiplying 3 4 times by itself will lead us to a result of 81. Then, writing this one into expression with rational exponent would be, our radicand would be the base of our exponential form. The exponent of our radicand will serve as the numerator of our rational exponent. And the index would be the denominator. And here, we notice that we have 4 over 4. So 4 over 4 is equivalent to 1, or we can write this one as 3 as our final answer. So this would be the expression in exponential form of fourth root of 81. Let's have the third one. We have fifth root of 36. So writing this one into exponential form, we will have first, 36 is a perfect square. So it is a result when we square 6. So 36 in exponential form is 6 squared. Then, we can write this one into exponential form as radicand will be the base. Then, the exponent of our radicand will be the numerator. And the index would be the denominator of our radical form. So that would be our final answer. So let's have our fourth example. Supposing we have square root of 3 over y to the fifth power. So how will we write this one in exponential form? Again, our radicand here is a fraction form, and that is 3 over y to the fifth power. And this radicand has an exponent of 1. So it follows that the exponent of this given expression is 1, while the index is 2. So we can write this one as 3 over y to the fifth raised to the exponent of our radicand, which is equal to 1, and the index, which is 2. So our final answer would be quantity of 3 over y to the fifth raised to 1/2. So this would be the final answer. So just bear to my dear math buddies that our expression containing rational exponents can be transformed into radical expression. Likewise, radical expression can be transformed into expression with rational exponent or the exponential form. Hope this idea will really help you as you solve your activities in your module. There you have it. Hope you learned something new today. God bless us all.